The concept of hell has been around since the dawn of human civilization, with various cultures and early spoken traditions passing down stories of an underworld fit for only the worst of sinners. For most iterations of hell, it has been a realm either below Earth or in a spiritual dungeon either on the planet or in another version of it. It's often described as an incomprehensible place of pain and suffering, rife with fire, flames, and temperatures not quite hot enough to burn you, but too hot to endure without torture. Surely this place couldn't exist, right? It's merely a folktale passed on through religion and spiritualism, the fabrication of mankind meant to strike fear into mortality. While it's very likely hell is not a real place here on Earth, it very well could be a real place somewhere out in the cosmos, hidden within galaxies and strewn amidst the stars. In fact, such a planet bearing the closest resemblance to hell we'll ever see was discovered in 2018, called K2-141b. Colloquially, it's known more appropriately as the Hell Planet. Without any other planet across the observable universe to compare it to, let's take a closer look at the magma-covered planet not even the fictional Mustafar could live up to. One of the most fascinating parts of K2-141b's origin story is that it came at the hands of a near disaster for the future of astronomy and exoplanet discovery. In other words, the ability to find the Hell Planet was almost ruined when in August 2013, scientists at NASA were nervous that their ultra-useful Kepler Space Telescope was nearing the end of its lifetime. It wasn't out of the realm of possibility that the Kepler telescope might die before a single new piece of data ever entered the computers at NASA again. Due to a mechanical malfunction in the telescope's internal wheel housing, the Kepler entered a thruster-controlled safe mode, making it impossible for the telescope to stay fixed on a target exoplanet without drifting off its intended course. Obviously, the error removed the major point to operating Kepler in the first place. Hunting planets orbiting various stars across deep points in the cosmos was the only thing keeping the program running. Luckily, a group of engineers located at Bull Aerospace in Boulder, Colorado, were quick to concoct a solution. They determined that if the Kepler telescope were to fall under the pressure of controlled sunlight, the machine itself would stabilize and conduct exoplanet hunting missions once more. Specifically, if enough photons from the sun's light waves made impact with the telescope, Kepler would enter a state of equilibrium, a point of stable balance. NASA used the example of balancing a pencil on your finger. Using the sunlight would be the same as finding that perfect resting place for the pencil to remain on your finger. Once the sunlight activated the solar panels on the telescope, Kepler had 83 days to study a specific portion of the night sky. After 83 days, the telescope would be rotated to block out any sunlight from hitting it, giving it another 83 days to study a new portion of the cosmos. After the second 83 days, Kepler would remain in a non-active state until it was positioned to retain sunlight in a new direction so that a third portion of the sky could be studied for 83 days. This process lasted until October 2018, when the Kepler Space Telescope was officially retired by NASA. Overall, the Sunlight Balancing Act, officially called the K2 Special Light Mission, was branded a success, and the Bull Aerospace team of engineers were applauded for their efforts. Of course, it's these efforts that unveiled an entire collection of new exoplanets strewn about the universe, including that of K2-141b. It started right before the retirement of Kepler, sometime in mid-2018. The telescope was capturing the light of the star K2-141, and using the transit method of detecting exoplanets, it was determined a tiny mass was blocking some of K2's light between our line of sight on Earth and the planet's central host. The transit method is only useful in determining the radius of new, far-out planets, and to learn more about this tiny blip against K2-141's orange main sequence backdrop, NASA employed a second approach to learn more. This time they wielded the Harp's-N spectrograph, which uses radial velocity to calculate an object's mass. With these efforts combined, astronomers could piece together exactly what K2-141b was, and the basics on the planet's makeup was only the beginning of the Hell planet's rise to infamy. It didn't take long after the measurements came in that astronomers were excited about the prospect of studying a new super-Earth, some of the more fascinating objects across the cosmos. Super-Earths are any extrasolar exoplanet with a larger mass than that of Earth, but still significantly smaller than the masses of the ice giants in our local solar system, like Neptune or Uranus. Specific to K2-141b, the planet remains at a mass of 5.08 times the mass of Earth, leading to a density of around 8.2 grams per cubic centimetre. This is nearly 1.5 times the density of our home planet, meaning the Hell planet most probably features a massive iron core, making up anywhere between 30 to 50% of K2-141b's total mass. In terms of radius, the Hell planet's radius is 1.5 times the radius of Earth. It takes about 1.6 Earth radiuses for most super-Earths to reach the threshold where planets feature a huge accumulation of helium and hydrogen atmospheres. This type of transformation would make the planet more like a mini Neptune than a super-Earth, and would make it much less likely the planet could teach us anything about terrestrial planets across the universe, or allow us to discover celestial objects as unique as the Hell planet. Among the many eye-popping qualities of K2-141b that set it apart from the rest of its highly unusual orbit, featuring some of the shortest known orbital periods astronomers have ever calculated for a newly discovered exoplanet. In total, the Hell planet only needs about 6.7 Earth hours to complete its orbital period around the host star. For a planet of its exact mass, it's the fastest orbit of any similarly sized planets around the observable universe. Because of the short orbit and extreme proximity to the star K2-141, astrophysicists widely agree the Hell planet is probably tidally locked with its main sequence host. Tidal lock means an orbiting planet only ever faces its host star from one side, making one side of the planet incredibly hot and bright at all times, while the far side is much like the Moon, constantly shrouded in darkness and much cooler than its star-facing facade. To understand just how close the Hell planet is to K2-141, Mercury is 41 times farther away from the Sun than the fiery super-Earth is to its host star. If you thought Mercury was warm, it pales in comparison to the hypervolcanic atmosphere of space's Hell. Without a doubt, the most intriguing part about K2-141b's existence is its absolutely vicious atmosphere and climate. It doesn't take long to realize how and why it received its now infamous namesake. For starters, the external temperature of the Hell planet at equilibrium is a scorching 2039 K. This translates to a temperature of either 1766 Celsius or 3211 Fahrenheit. When the planet isn't in a state of equilibrium, the external temperatures are probably much higher, depending on its proximity to the host star at any given time. At peak temperatures, astronomers believe K2-141b reaches temperatures as high as 3000 Celsius and 5430 Fahrenheit, readings so high that solid rocks would be completely melted and then vaporized. In addition to the ravaging heat, nearly 2/3 of the Hell planet's surface is submerged in infinite daylight. If one were able to live within these regions of the planet, they would go their entire lives most likely never knowing what the night sky looks like. Life on the other side would be the complete opposite. Vitamin D would be as valuable as currency, as not a single ray of light would permeate the atmosphere. In fact, it would be so dark that despite the flaming hot temperatures of the super-Earth's sunny side, the dark side would feature bitter cold temperatures, plunging all the way below 73 K, or -200 Celsius and -328 Fahrenheit. K2-141b also contains expansive oceans consisting of magma and melted minerals. These bodies of magma vaporize into the atmosphere, and the output of mineral vapor then is swept to the dark side of the planet via torrential winds faster than the speed of sound. Once the mineral vapor is on the far side of hell, the cold temperatures cool the condensed air, and the mineral vapor transforms back into solid form. This creates a rain shower of thick rocks that proceed to fall back into the oceans of magma. The cooler seas of magma on the frigid side then form currents that seep back into the bright side of K2-141b, where the rocks in the magma will evaporate, and the entire cycle is started once more. Imagine the worst hurricanes and typhoons originating over the Atlantic Ocean here on Earth, then replace all of the water with flaming rocks, toxic vapor, and waves of lava. That's the everyday weather report on hell. In terms of an atmosphere, K2-141b consists of the high-speed winds as mentioned before, blowing at average speeds of 1.75 kilometers per second, over 5 times that of supersonic speeds. The rest of the atmosphere is made up of the aforementioned vaporized minerals. These are most likely minerals and assorted metals we would only ever find in solid form on Earth, making their composition and relationship with the planet a total mystery. One element confirmed to be found in solid form on K2-141b is sodium, one of the most prolific metals on the Hell planet. In fact, the amounts of sodium are probably so high, massive chunks of its solid form most likely slides from the planet's poles towards its magma oceans, mirroring the movement and melting of ice glaciers here on Earth. So while K2-141b may be classified as a super-Earth, the terrestrial exoplanet is the farthest thing from it. Between the volcanic oceans, the unbreathable atmosphere, the mind-melting temperatures, and perpetual light and darkness, the Hell planet receives its moniker without a second thought. If one were to point it out in the night sky, they would need to first find the constellation known as Pisces, and rocket 202 light-years towards that general direction. Here they'd find the host star, known as just K2-141, an orange main sequence star, estimated to be as old as 12.9 billion years old, nearly the age of our universe in total. If the Hell planet has truly been around as long as Hell itself, it makes us wonder, what if those hell-bent on entering the underworld post-mortem found themselves flung through 62 parsecs of the cosmos, only to end up on K2-141b? While it's highly unlikely, it simply can't be ruled out, for the planet really is befitting only to Satan himself. Make sure to subscribe and switch on the notification bell to not miss next week's video.